Hello everyone, here is a question based on dipole moment. The number of non-polar molecules from the following is how many? To decide whether a molecule is polar or non-polar, we need to know the dipole moment of a molecule. So therefore, polarity depends on dipole moment. If the dipole moment is 0, then we can say the molecule is non-polar. On the contrary, if the dipole moment is non-zero, then we can say the molecule is polar. So now, in general, the homonuclear diatomic molecules will have zero dipole moment. So for example, this is homonuclear diatomic molecule H2. For H2, the dipole moment will be 0. So therefore, we can count that. On the contrary, heteronuclear diatomic molecules such as HF, HCl, for these ones, the dipole will be non-zero. Why? Because of the electronegativity differences. So basically in HF, the dipole orientation will be this way because fluorine is more electronegative than hydrogen. Likewise for in HCl2, the dipole moment orientation will be this way. And in polyatomic molecules, if the dipole moment is 0, it is mostly due to symmetry. So for example, in CO2, we do have polar bonds. However, they cancel each other. One is in this direction, but another is in the opposite direction. And therefore, the dipole moment will become 0 in CO2. So this means we can count this one also. In H2O and SO2, they are not linear molecules. So therefore, we will have dipole moments in those molecules. In H2O, this is the molecule. So there will be a net dipole in this case, in this direction. So therefore, the dipole moment for water is non-zero. Likewise for SO2 also, because SO2 is slightly bent because of lone pair, bond pair repulsion. So therefore, we will have dipole moment for this molecule too. So here also the dipole moment will be non-zero. So we can't count those. How about CH4? In methane, because of symmetry, because it is tetrahedral, because of symmetry, the dipole moment will be 0. Therefore, we can count methane. NH3, the dipole moment will be non-zero. So we can't count that. Like methane, the hybridization of the central atom in ammonia is sp3. However, the dipole moment is still non-zero in this case. Even though the hybridization is same, just like methane, when it comes to dipole moment, it becomes non-zero because we have a lone pair of electron whose dipole orientation would be in this way. And also, the molecular geometry of ammonia is trigonal pyramidal, not tetrahedral. So therefore, the dipole moment is non-zero for ammonia. For trichloromethane, the hybridization of the central carbon atom is sp3 and the geometry is tetrahedral, just like methane. However, the dipole moment will be non-zero in this case because we have two different kinds of bonds. One is the CH bond and another is the CCl bond, and therefore the net dipole moment will be non-zero. If it is CCl4 tetrachloromethane, then the dipole moment will be 0. But we don't have CCl4. We have CHCl3, trichloromethane. Therefore, for trichloromethane, the dipole moment is non-zero and we shouldn't count that. BF3, once again, because of symmetry, the dipole moment will be 0. Fluorine is more electronegative than boron. But still, because of the symmetry of the molecule, the dipole moment will be 0. So this means that we have 4 molecules where the dipole moment is 0. Therefore, the correct answer is 4 here.